Alright, ratios. This is a multiplicative comparison of two quantities. So we take two things and we write them as a comparison. This is a 1 to 2 ratio. We can also say 1 to 2 ratio, or using the colon, which is 1 to 2 ratio. Alright, we've all heard this before, ratio in some form, and that's what we're dealing with today. So, what I want to do is to write the following as a ratio in fraction form. Okay? So, the first one would be 3 to 5. We would just put 3 to 5. Number 2, that's 14 over 21, so it's a 14 to 21 ratio. But we want to simplify this. So if they have a common factor, you want to reduce them just like any normal fraction. So 14 to 21 is the same as a 2 to 3 ratio. And the simplified form is the best form to be used. Not always, but for the math form that we're doing, we want it in the simplified form. Alright, well, what if you have a decimal? This is 0.9 to 0.6. What you can do is you can just treat it like we would do a normal division, which allows us to take that decimal and move it out. But if you do it to the top, you must do it to the bottom. So it gives us this. It's a 9 to 6 ratio, which we can reduce into a 3 to 2. These are all the same. They are equivalent. So 0.9 to 0.6 is the same as 9 to 6, or it's the same to 3 to 2. So you can also convert 3 to 2 to 0.9 to 0.6. You could do it to 0.3 to 0.2. But again, we're doing simplified. We want the ratio in the simplified form. Alright, what if you have units? So we have 8 ounces to 1 pound. You must include the units. And if the units are same type, in this case they're both weights, we have ounces and we have pounds, then you must convert them to the same to give a nice clean comparison. So 1 pound would be the same as 16 ounces, and this is the reason why. And now we can just cancel them and reduce, which gives us a 1 to 2 ratio. So if they are the same type of unit, we're talking about distance or weight or time, convert one unit into the other and then reduce it. By the way, for 1 pound it's 16 ounces. That's why I put 16 ounces. So if you have 1 pound, it's the same as 16 ounces. Alright, let me do one more and then I'll give you one to try. So we have 3 inches to 15 inches. These are the same units, which means we can cancel them. And then 3 and 15 will reduce into 1 to 5. So 3 inches to 15 inches is the same as a 1 to 5 ratio. And the reason this is nice is you can now say it's a 1 yard to 5 yards, or 1 mile to 5 miles. You can put any distance you want up there, top and bottom, same distance, and it'll give you that same ratio. Okay. So I want you to try number 6 and number 7. Hit pause, give them a shot. Alright, and you should have gotten a 1 to 16 ratio for number 16 and a 1 to 6 ratio for number 7. So for every foot you have 12 inches. So 4 feet is the same as 48 inches, which allows us to then cancel the inches, reduce the fraction to 1 to 16. And then we have 4 hours to 2 days. And by the way, if you notice, each time you write it, you have to put the first number on top, the second number on the bottom. Order really does matter here. So, those are your answers. Alright, how about these then? Here's some practice problems for you. Let me have you try number 8. So write the ratio of monthly cost of gas to monthly income. Hit pause, give them a shot. Alright, and there's what you should get. It should be a 3 to 25 and a 38 to 25. Alright, so I know we've all used ratios before. You've probably mixed up some sort of cleaning solution at some point, or even just made orange juice. Those are ratios from a concentrate. Maybe not, but here is one application of it. It's a nice little thing that ratios can do. So if you see 5 of every 6 students interviewed, this is a fraction. So if you were to draw out 6 students, we would know that 5 of them favor a change. So we're going to put F. Let's read it again. 5 of every 6 students interviewed favor a change in library hours. So that means favored, 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 does not favor. And that's the picture of the solution. This now gives us a ratio. So it says among those interviewed, what is the ratio of those who favor a change to those who do not favor a change? Well, how many favor a change? Those who favor a change, there are 5. 2, that's our little ratio. Those who do not favor a change, 1. That's a 5 to 1 ratio. Do not write 5. This is not like a fraction. This is a ratio. They do have similar quantities, but they are not the same thing. So it's a 5 to 1. Among those interviewed, what is the ratio of those who do not favor change to those who do favor change? So there's the 2. And all you have to do is replace the wording with the number. Those who do not favor a change. Well, there's 1 of them. 2. Those who do. 5. It's a 1 to 5. This is why order matters a lot. The thing that goes in front of the 2, the wording that goes in the front of 2 has to be the numerator, and the wording that goes behind the 2 has to be the denominator. So it is a 1 to 5, and it is a 5 to 1. Now here's the clean, nice thing about ratios. It says find the number of students who do not favor a change. The number of students who do not favor a change is blank times the number of students who do favor a change. So watch this. If you treat it like a ratio, so the number of students who do not favor a change, 1, times the number of students who do favor a change, it's 5. The answer here is the ratio itself, 1 to 5. If you don't believe me, let's figure this out. It says the number of students who do not favor a change is, so do not favor a change is 1/5 times those who do favor a change. Well, how many people favor a change? 5. So if we plug it in, gives us 1 who does not. The ratio itself is the number of times one is in terms of the other. So let's watch. I kind of rewrote it a different way here. The number of students who do favor a change is blank times the number of students who do not favor a change. So the number of students who do favor a change, how many are there? How many students favor a change? 5. All right. Is blank times the number of students who do favor a change, 1. So what is the ratio of students who do favor a change to those who do not favor a change? It's a 5 to 1, which means the number of students who do favor a change is 5 times the number of students who do not favor a change. Isn't that kind of clean? So if you go back up here and look at it, it says write the ratio of the monthly cost of food to the monthly cost of gas. So the monthly cost of food is 38/25 times the monthly cost of gas. Or write the ratio of monthly cost of gas to the monthly income. If we put that in a times form, the monthly cost of gas is 3/25 times the monthly income. Watch. So cost of gas is 3/25 times the monthly income, because that is our ratio. Plug in the monthly income. Remember, that's going to just cancel and give us 1,000. 2,500, so it'll give us 100, extra 0 there, which gives us 300. It'll work every time. So that ratio can be turned into a multiplication. Nice. Thank you.